All right, we are problem 2, and we're working with PTO3, and we're working with PTO3, and I want to dope the material with this. PTO3 can form this defect, this defect, this defect. It has this enthalpy formation, this, and this. So this will be our dominant defect because of this expression, which is exponential minus delta HF enthalpy formation over KT. Now, we need to write out all the intrinsic defects, so we need to do null goes to a vacancy in PT. PT will be plus 6, so that's going to be 1, 2, 3, 4, 5, 6, plus vacancy in oxygen, which is just 2 positive here, so we need 3. If we do PT, PTX, vacancy in PT is 1, 2, 3, 4, 5, 6, plus a PT interstitial, 1, 2, 3, 4, 5, 6. Oxygen X goes to vacancy in oxygen, 1, 2, plus oxygen interstitial, 1, 2. Fantastic. So, can I put a host atom on the X location? No. Can I put an impurity vacancy on the X location? A vacancy could only be in the host, so no. Can I create a vacancy in my host for an extrinsic reaction? Yes, you can. What about placing an impurity atom on an interstitial site in the impurity? What about placing an impurity atom on an interstitial site in the impurity for an intrinsic reaction? So that is not true. I can't put an impurity atom on an interstitial impurity site. I can only put an impurity atom on the intrinsic, or on the. There's no impurity actually at all for an intrinsic reaction. So that's just a nonsense statement. Excellent. Write a defect reaction. Okay, so now we're getting to the business. So, write a defect reaction that incorporates a cation substitutional. So we're doping. I'm going to dope the material with this. This is our dopant into PTO3. So cation substitutional. So TA where PT needs to be. PT is 6. TA is 5. So it's going to be a -1. Plus, so now we need a positive, so vacancy in oxygen. So we need 1, 2. So let's go ahead and get that there. Vacancy in oxygen. So now we'll put this 2, good. So we have 2, so we need 5 oxygen, so 5 oxygen, oxygen X. What about PT? There's 2 PT, so we need 6 oxygens, done. Great. TA2O5, PT03. We need a cation interstitial, so we need TA 1, 2, 3, 4, 5 I plus a vacancy in PT. So that's 1, 2, 3, 4, 5, 6. So I need this to be 5, I need this to be 6, so that's a 3 plus 15 oxygen, oxygen X. Good. 6 TAs, PT. How many PTs? We have 5, and then we need 15 there. Good. And then finally an anion interstitial, TA2O5 goes to PT03. So I need an oxygen interstitial, that's -2, plus TAPT, -1, plus, let's do a vacancy in oxygen. So we need 2 of these, and then let's do 2 of these. We're good. So, and then we need plus 4 oxygen, oxygen X. Good. So PTs, we have 2, so we need 6. So 4, and then 2. That's it. Done. See you on the next problem. Bye.